Welcome to myprojectbazaar.com. Our project title is an evolutionary self-cooperative trust scheme against routing disruptions in manets. Abstract. How to achieve reliable routing has always been a major issue in the design of communication networks, among which mobile ad hoc networks possess the most adversarial networking environment due to the absence of fixed infrastructure, the nature of open transmission media, and dynamic network topology. These characteristics also make the design of routing protocols in manets become even more challenging. In this paper, we propose a evaluationary self-cooperative trust ESCT scheme that imitates human cognitive process and relies on trust level information to prevent various routing disruption attacks. In this scheme, mobile nodes will exchange trust information and analyze received trust information based on their own cognitive judgment. Eventually, each node dynamically evolves its cognition to exclude malicious entities. The most attractive feature of ESCT is that they cannot compromise the system even if the internal attackers know how the security mechanisms works. In this paper, we evaluate the performance of ESCT scheme under various routing disruption attack situations. Simulation results shows that the ESCT scheme promotes network scalability and ensures the routing effectiveness in the presence of routing disruption attackers in manets. Let us see the flow of our project. First, we have to model our network in the sense of 1000 cross 1000 meter range. Then in our network have 50 number of nodes with mobile ad hoc network. So the nodes are sensing the range and the mobility is set for random waypoint model, which have the 10 second speed. We also calculate the energy, distance as well as the position of the node, each nodes. Then the source will be transmit the data to the destination via that neighbor nodes. If the ESCT achieved, that is, we have to identify the self-cooperative detection, that is, self-detection and cooperative detection for achieving ESCT scheme. If those things were achieved, we have to transmit. We have to consider that neighbor node as a trust node, and we have to transmit via that neighbor node. We use DSR protocol for routing purpose. Then optimal solution were achieved. Data transmission is done via that safest trust node. Then we have to allocate data transmission in transmission control protocol TCP. Performance evaluation is done based on delay, throughput, packet delivery ratio, and the energy consumption. Let us see the output of our project. For that, we have to open VMware workstation. Now I am going to run the NS2 simulation using terminal windows. For that, opening the terminal window. Then we have to go to the directory for the code folder. This is the syntax for running our main.tcl file, which is main for all the file. So the number of nodes set is 15 nodes, and the channel is set is wireless communication channel. Now the data transmission and the trusted calculation is done. This is nothing but the trust scheme calculation, that is, we implement evolutionary self-cooperative trust scheme, which contains abnormal leaving, abnormal joining, and normal leaving moves. So we have to calculate all those things which is related to each mobile nodes. So the data transmission between 25 time will be go to the NAM window. So after it receives the packet means, yeah, now Now this is for our lamp window. So now I am going to set speed as 20 milliseconds. So this green color denotes the energy consumption for each node. So 50 number of nodes aligned in the range of 1000 cross 1000 meters. Now the data transmission between the source and the neighbor node is done. So the source node is node 0 and the neighbor node is 4. For that, node 0 send the data to neighbor node 1. So it is in normal living. That's why it is not in adversarial moment. All the nodes are in random waypoint model mobility. The data transmission is done by using TCP and the DSR protocol. So this is for TCP data transmission which is at 16.4 seconds. The bytes of 11,018. So 1118 bytes are transmitted. Finally it will be transmitted to the destination, which is node 4. So these rounds are nothing but the beacons. So this produce 3 types of beacons like CTS, RTS and the acknowledgement. So this is for RTS and one more beacon is acknowledgement ACK. Finally data transmission between 3 to 4 is done. So now I am going to run the simulation performance evaluations. For that, type AWK space. I am going to run the energy consumption graph. Energy AWK space -F space energy dot AWK and the trace file. So now it will be set the energy for overall nodes and average energy. So now xgraph space energy.xg for opening that energy graph. This is our energy graph of our proposed ESCT scheme. Thank you for watching.